In this video, I'm going to walk you through lesson 12 of unit 7.1 from Open SciEd. Okay, this is kind of a putting everything together lesson. In the last lesson, we wrote some explanations individually and models, and so we're going to compare those in small groups. There is a protocol for doing this. Here's the slide to support you. Basically, it's just going to talk about who's going to talk first. We're going to move clockwise around the group. We're giving each person a chance to share their model and their explanations. They're going to discuss how the model helped them understand something that was at a scale too small to see. That's really using that lens of thinking of the cross-cutting concept for scale, proportion, and quantity. And then we're going to think about any questions we still have left and how we can improve our models before we move forward. Then we're going to revisit our consensus model, and I would remind you it looks like this. And so we're going to talk about those question marks that we weren't quite sure what was happening in those question mark moments. And so we use the molecular cutout manipulative. It looks like this. And these are all the molecules that are in the chemical reaction. And so we're going to use these, we're going to cut them out, we're going to put them on our consensus model to show what's happening when the molecules break apart and rearrange to make new substances. We're going to earn the term, finally, for product and reactant. So you're going to define these as a class, and you're going to add these to our word wall. Then we're going to take an individual assessment. So basically everything we're doing up until this point is a review and getting them ready for this individual assessment. It's called explaining new aspects of the anchoring phenomenon. We call this a near transfer task, which means they're going to use the science ideas that they have been developing throughout the unit for the actual anchoring phenomenon that we've been studying. A far transfer task is a new context or a phenomenon that we have not been studying, and that will be in lesson 14 when we do the assessment on the Taj Mahal. But this is a nice summative assessment of the whole unit, and we're going to see if students can actually explain the aspects of the anchoring phenomenon that we've been trying to figure out. And I don't link it because I hopefully do not want to give the assessment to students who have found my videos or website, but it is in your Google Drive. Okay, then we're going to compare our models on the assessment with a partner. So we're going to actually share some of our ideas on the assessment. Here's the slide to support you. There's a couple questions we're going to think about. There is a day break if you're not on block schedule. So obviously this would be the next day if you have regular short classes. And we're going to discuss which claims we can make about which substance could be produced from the bath bombs. It's just really a final explanation. And we continue to revise the consensus model by considering how many molecules of products and reactants should be in the chemical reaction. Now we do this by comparing two chemical reactions. So let's take a look at this handout. And basically what we're pushing students towards is figuring out if you count the number of atoms on one side, they should equal the number of atoms on the other side. And only Model B does that. And so it looks like the purple is real easy to identify, but the hydrogen and oxygen, they're going to need to count up. There's way too many hydrogen and oxygen on this left side because of these parts of the reactants here compared to what's over here. So Model B is going to be what they decide is the correct amount of atoms on both sides. So we'll talk about coefficients. We need one of these, three of these, three of these to make one of these, three of these, and one of those. Okay, we're going to put that on our consensus model. And if your students are struggling, I would say you can do this with the 2D molecules of water. I'm not sure they're going to need this. Kind of read the room, see if they're there. If they're not sure what's happening to water in that chemical reaction, definitely pass these out and they're going to rip them apart. But this really is something that you might have already hit with that electrolysis and adding energy to water investigation. Okay, we're going to record our ideas on a poster, and this is again something that is kind of revisiting those ideas that we figured out with those adding energy to water investigations, and it's the difference between chemical reactions and phase changes. We're just basically going to chart them, atoms rearrange to make a new substance. Over here in phase changes, they do not rearrange, they just change their state, and no new substance is made. We know this because of the property tests. Dissolving, though, we're still not sure about. So we're recognizing the fact that we still don't know exactly what happens with dissolving. And that's okay, because some ideas we might actually figure out in high school, and that's perfectly fine. Okay, we revisit our driving question board, and when we do this, we realize that we still have questions about the odor and what the bath bombs smell like. So that is going to help us navigate into lesson 13, where we're going to hit a life science standard. But before we do that, let's talk about the materials prep in the next video.